Okay, good day. So we will discuss now how to solve a Cartesian vector using position vectors. From the previous lesson, you must learn how to find position points of a vector. Okay, so since these are the given, we have to find the position vector first. Okay, so these are the position, and the position vector is r is equal to x2. So that is the point at point 2 minus, so that is final point minus initial point. So this is final point x2 minus initial point x1 I hat plus y2 minus y1 j hat plus plus x2 minus x1 k hat. Okay, so here this is now the Cartesian vector of a position vector. So but our goal is to find the Cartesian vector of a force. So we have to remember, even though these are given in position as points, and this is the length of your force, the length of your force is also in the position in the same length of your position vector r. So it means F and position r have the same unit vector, which is this. Okay, so that will be the unit vector. So it means from here, the position vector r, I can extract the unit vector of this by solving force r, or the position vector r, times its magnitude times its unit vector. And we know that unit vector can be solved as position vector divided by the magnitude of its vector. So that is the magnitude of position vector. And we have to note that a force vector is also a magnitude of the force times its unit vector. Hence, since they have the same position, they have the same unit vector, I can say that I can solve now my force using the magnitude of my force times the unit vector of my position vector. So that will be F, the magnitude of F given, times U. This is an example of a vector that is not starting from its origin. So this is the position of point A and this is the point B. And based on the problem, the magnitude of our force vector is 70 pounds. We have to express this force into Cartesian vectors. We are also going to determine the direction angles of this force vector. Let's determine first the points. So this is point A. So along X, it's along on the origin. So that will be 0. Along Y, it's still not moving along positive or negative Y. So that is also 0. And for Z, it's going up. So that is above origin. So that is 30 feet. Okay, so that is my point A. So this is my point B along X. So that is 12 feet. So that is 12. For along Y, so if you can see, that is going to negative Y. So that is 8. So that is negative 8. Because it's going along negative Y. And the height of this point V, so that is going up above the origin, going to positive Z axis. So that is 6 feet. So we now have the position. Let's solve now the position vector. So R, the formula for R is equal to x2 minus x1 I hat plus y2 minus y1 j hat plus z2 minus z1 k hat. Okay, so that will be x2 is this. So that will be 12 minus 0 I hat plus y2 is negative 8 minus 0 j hat plus z2 is 6 minus 30 k hat. Hence, my r now is 12 I hat minus 8 j hat, then minus 24. So 6 minus 30, that is negative 24 k hat, and that is feet. So as you can see, if it has positive x, negative y, and negative z. So it means, because we assume the origin of our vector r, so it means that is along positive x, negative y, and negative z, if this will be the origin. Okay, so as if we will move our vector going here. So that's the reason why this is the our x component is positive, our y component is negative, and our z component is negative. So let's find its magnitude so that we can extract our unit vector. So r is equal to square root of rx squared plus ry squared plus rz squared. So that will be square root of 12 squared plus negative 8 squared plus negative 24 squared. And my magnitude is, so r is 28 feet. And let's solve now the unit vector. So the unit vector is 1, so that is r over the magnitude, so that is r is equal to rx over ri hat. So this is the formula, ry over rj hat plus rz over rk hat. And that will be, so that is 12 feet over 28 feet I hat plus negative 8, so that is negative over 28 j hat plus, that is negative 24 over 28 k hat. And this will be, so that is 12 divided by 28, so that is 0.43 I hat minus 0.29 j hat minus 0.86 k hat. And this is now your unit vector. So we will now use our unit vector to find our force. So that will be, so force is equal to F times its magnitude times its unit vector, U, which is this. So that will be 70 pounds, that is the given, times 0.43 I hat minus 0.29 j hat minus 0.86 k hat. So that will be, our force now is 70 times 0.43, so that is 30.1 I hat. 70 times negative 0.29, so that is negative 20.3 j hat. Then 70 times negative 0.86, and that is negative 60.2 k hat. And the unit of this is pound. This is now the Cartesian vector of our force. So as I say, we are also going to find the angles of this, since the force is positive x, negative y, and negative z. So this is the position of our force. So the reason why I have to put it like this, because all angles should be coming from positive x-axis to the vector. We cannot do that here in this type diagram, so we have to put the origin, so the start of the vector, into as if that is the origin of our axis. So here we will get what is alpha, so this is alpha. We will get the beta, so that is, since our vector is in negative y, so that will be higher than 90 degrees. And we will also get the gamma, that is also higher than 90 degrees because our vector is in negative z. So let's solve. So to solve the direction angles, we will use the force we have computed a while ago to solve the angle. So here, so cosine alpha is just equal to fx over f. And we know fx is 30.1 and the magnitude is f. So it will be just alpha r cosine. So that will be 30.1 divided by 70 pound. So the units will be cancelled. So alpha is equal to, okay, so alpha is equal to 64.53 degrees. That is for alpha. And for, let's solve for beta. So that will be cosine beta is equal to fy over f. So that will be beta is equal to r cosine, and fy is negative 20.3 divided by 70, and the answer of our beta is 106.86. Okay, so we have a higher value here because we indicated now our fy as negative. So for gamma, so that is our cosine gamma is equal to fz over f. So that will be gamma is equal to r cosine. So that is negative 60.2 divided by 70. So that will be, okay, so that is 149.32 degrees. So this is how to solve Cartesian vector using position vector.